Okay, we can go on the second paper, improving critical infrastructure protection by enhancing software acquisition process through blockchain. The authors of the paper are Jelena Marjanović, Nikola Dalčeković, and Goran Sladić. Jelena will give the presentation.
My name is Jelena Marjanović. I'm a teaching assistant at Faculty of Technical Sciences at University of Novi Sad, and today I will be presenting our paper, Improving Critical Infrastructure Protection by Enhancing Software Acquisition Process through Blockchain. Nikola Dalčeković and Goran Sladić have also worked on this paper with me, and you can see our email addresses to which you can contact us. So for this session, I want to go through our motivation for this paper. And before I can explain what the blockchain model for tracking software component is as our proposed solution, I will go through some blockchain basics, as it is important to know blockchain concepts to understand our solution. I will also cover what the current trend is and what other authors have covered in their articles. And after the proposed blockchain model, I will summarize our work and explain our future steps. And at the end, there will be time for your questions. So what was our motivation for this paper? Someone can argue that organizations' weakest links are supply chain attacks, as organizations sometimes fail to track the software components that are introduced into the system. So to increase organizations' security, tracking every action of integrating procured software components into an existing system, which can include analyzing vendor security or auditing organization supply chain, that's something that should be done. So let's say we have an organization that saw an excellent tool on the market and decided that they want to install it on their system. And by not inspecting vendor security, that tool or any other software component that was brought into the system can introduce vulnerabilities into the system, making the whole system vulnerable, and that can be a huge problem for industrial control systems. So what we propose is to track the software components that are introduced into the system, whether they are commercial off-the-shelf components or tailor-made components, and track their security analysis by utilizing blockchain technology. So blockchain technology provides a tamper-proof solution for tracking the information that is stored on a ledger, while at the same time allowing only pre-authorized actors to participate in the network. So we have chosen Hyperledger Fabric for this solution, as it is intended for enterprise solutions, and it is a permission blockchain network, which means that only pre-authorized actors can participate in the network. Even though blockchain as a technology was introduced like more than 10 years ago, there is still some confusion about what it really is. So Bitcoin is a cryptocurrency as well as Ether, and they are built utilizing blockchain technology. So blockchain technology is used for cryptocurrencies, and that is the tokenization part of its usage, but it can be used for much more than that. So because blockchain is a decentralized and distributed ledger, which consists of blocks, it can be used for decentralizing information, and as such, it can avoid single point of failure. So when we have a network of blockchain nodes, every node contains the latest copy of the ledger, and if one node fails, all other nodes are still holding the ledger and can continue to work normally. So one example are obviously supply chains, where multiple interested parties contribute to the chain and have the same goal, and that is to have the information available and verified. So a live example is a supply chain for tracking diamonds from mines to the customers. And that is something you can go up and see on the internet. What I want to cover next is how the blockchain is maintained and how are the blocks created. So here on this picture, we can see that the first block in the blockchain is called the Genesis block. It's a starting point for the ledger, and it does not contain any user transactions. Instead, it contains a configuration transaction that contains the initial state of the network channel. Then we can see our blocks and blocks header, and each blocks header includes a hash of the blocks transaction, as well as a hash of the prior blocks header. In this way, all transactions on the ledger are sequenced and they are cryptographically linked together. And this hashing and linking makes the ledger data very secure. So even if one node that hosts the ledger was tampered with, it would not be able to convince all other nodes that it has the correct blockchain, because the ledger is distributed throughout the network of independent nodes. So also in this diagram, we can see that the block B2 has block data D2, which contains all its transactions, D5, D6, and D7. What's even more important is that this block B2 has a block header H2, which contains a cryptographic hash of all the transactions in D2, as well as the hash of the previous block's header H1. So in this way, blocks are completely and immutably linked to each other. That means if someone wanted to change information in the B2 transaction, he or she would have to generate a new hash for that block and to update all the subsequent blocks as its header was changed. And since this is a distributed and decentralized system, it would have to be done on most of the nodes, and that's nearly impossible as there is no such a powerful machine. And so another concept that is linked to blockchain technology are smart contracts. They are decentralized and trusted share codes that are deployed on the blockchain. And for our solution, we have chosen Hyperledger Fabric over Ethereum blockchain, as Hyperledger Fabric is a private permission blockchain, while Ethereum is a public one. And a public blockchain means that it is available to everyone, both for reading and writing transactions, and that is not suitable for our solution, as vendors usually do not disclose their software components. So a private permission blockchain means that the network is maintained only by pre-authorized set of users. And another distinction between these two blockchains is the concept of channels. And they are a mechanism for creating private blockchain within the blockchain network, which provides data isolation and confidentiality for organizations that are participants in the blockchain and their applications, which are attached to the channel. Okay, so on this picture, we can see how a transaction is formed, and that is important because it justifies our proposed architecture. So first, what happens is that the client broadcasts the transaction invocation request to the peers. And these endorser peers check the certificate details and other details to validate the transaction. If the transaction, the verification check passes, peers will simulate the transaction and endorse the generated response. And if the transaction is rejected, rejection is sent as part of the endorsement response. The next step is that the client receives the endorsed proposal response from the peers, and it sends the approved transaction to the ordering peer in order to be properly ordered and included into the block. And that ordering peer or ordering service includes the transaction into the block and forwards the whole block to the nodes of two different member organizations on the network. And it also generates the blocks for all peers on the relevant channel. And the final step is for the client to receive any subscribed events if he has any subscriptions. It's worth mentioning that securing supply chain is not only an issue that the software industry is facing, but it is an issue that every supply chain should be aware of and should take proper action in order to increase its security postures. So some authors have pointed out that there is a lack of formal education on how to secure sourcing for commercial off-the-shelf products. And they said that there are courses that teach software engineers the importance of supply chain risk management, and they showed how those courses can be upgraded by proposing a process for secure acquisition based on their 10 principle of performance. Also, several other solutions have shown how supply chain can be improved using supply chain technology. So we have origin chain, which employs a geographically distributed private blockchain at the traceability service provider. And we have a trust chain solution, which uses a consortium blockchain to track interactions between supply chain participants and to dynamically assist trust and reputation scores based on those interactions. And also a step further was made, as some authors have analyzed cybersecurity attacks in supply chain while utilizing machine learning techniques. These papers provide the importance of a secure software supply chain, but the problem of immutability of supply chain is not addressed. And that is something that we have addressed in our paper, utilizing Hyperledger Fabric. So you can see our use case for blockchain model for tracking software components. And we have identified 3 actors that are involved in this blockchain model. So we have software component vendor, which represents companies that provide software that can be custom made for a specific customer, or can be a commercial off-the-shelf components. Then we have a purchaser, which is the company that will be using the software that software component vendor provides. And that is a generalization for actors which are named software component manager and security advisor. And also we have the actor auditors, and they can expand the whole process of tracking software component supply chain. We can see that every actor in this use case must authenticate to blockchain network to be able to participate in an activity. Okay, next, the actor software component vendor is responsible for filling the security questionnaire, which is then uploaded to the interplanetary file system, which is a distributed file system and is suitable for integration with blockchain solutions. Interplanetary file system, or IPFS for short, works in a way that someone uploads a file to that file system and receives a hash of that file, and he or she can query with that hash. And once a new version of that file is uploaded, a new hash is created. It's important to notice that by introducing IPFS to the solution, the blockchain remains solely for storing information on the ledger, which is the blockchain's purpose. Also, if software component vendor is producing a tailor-made software component, the code should be deployed in a predefined repository, and that repository is managed by a software component manager. The actor software component manager manages the software component repository, which is utilized by the software component provider. And we have the security advisor, which performs questionnaire analysis, which includes obtaining the file from the IPFS. And we have the actor auditor, which can inspect any of the ledgers once the purchaser and the software component vendor update the consortium. So the auditor is given the rights to read the ledger. And auditors can also inspect the security questionnaire. Here in this picture, we can see our proposed architecture. So every actor from the previous slide is a separate organization with its own certificate authority. We also see peers, consortium, ordering service, network configuration, applications for organizations, the channel and its configuration. So an organization is it's conceptual an entity and can be as large as a company, or it can be an individual, while a consortium is a collection of non-ordering organizations on the blockchain network. And those are the organizations that form and join channels, and they have their own peers. And a peer is a network entity that contains a ledger, and it runs the smart contracts in order to perform operations on the ledger. So software component vendor and purchaser are organizations, and they form a consortium, which means that they both have the ability to update the channel. And with that, they can add new organizations to the channel. So when the external auditor wants to inspect the channel is updated by the software component vendor and the purchaser, and they both have to agree on this. And once they agree, the auditor is added, and once the auditor is finished, they update the channel once again and remove auditors' rights to that channel. So software component vendor and purchaser have their own peers, and they run the smart contracts, and they have their own applications that are used for communicating with the channel and with the IPFS. And once the auditor is added to the channel, they have their own application. That application will be available to connect to the channel and inspect the process and the information that is stored on the channel. Here we can see that there is only one channel, because all smart contracts that are necessary for the solution are stored there. Okay, from here we can see how actors can use this solution through smart contracts. So the organization software component vendor has its own application for accessing the IPFS and the channel in blockchain network, which we saw on the previous slide. And this application is used for invoking security questionnaire smart contract. And whenever a software component vendor fills a security questionnaire, a method that is called put questionnaire to IPFS is invoked from the application, which returns the file's hash. And that file's hash is stored on the ledger by invoking a function upload questionnaire hash from the smart contract. And that means that security advisors can query security questionnaires by their hash, which is done by invoking a function that is called security questionnaire, a function from security questionnaire smart contract. And this method can also be utilized by auditors in their applications. So if any changes are made to a certain security questionnaire, security advisor can call the function put questionnaire to IPFS, which will return updated information about the questionnaire on the IPFS. And that makes it possible to upload the information to the ledger by calling the method upload questionnaire hash. So to conclude, tracking vulnerabilities of procured software that is introduced into the system should be done because it increases the security posture of the company and the system. And the system has another check for vulnerabilities. So audit of this process should also be performed, as it is a way of double checking whether processes are in place, as well as the technology that enables it. And given the analyzed use cases and the proposed architecture, it can be concluded that Hyperledger Fabric blockchain provides the necessary trust in a multi-party environment, which is the basis for more efficient auditing of the whole process, because the trustworthy logs are an out-of-the-box blockchain feature, and we have easier auditing, and those are the key enablers for a supply chain management process that can address the described needs. And also by utilizing IPFS and the blockchain ledger, the information that is stored is immutable, and those defined organizations enable only pre-authorized members to contribute to the ledger. So our future work relies on creating a test environment for this solution and expanding the solution with another channel, which will create a possibility for new actors to be introduced into this solution. So thank you for your time and your attention. I believe we have lots of time for your questions.
Thank you, Jelena, for presentation. Any questions? Okay, I have one question just to clarify something. Is this solution capable to support multiple software vendors? So if I'm some kind of big company that buys software from different vendors, can I use the blockchain to control software by the all vendors?
So if we want to see all vendors in one place, we can use this solution as it has only one channel. But if we don't want our vendors to see each other, we can duplicate this solution and make another channel that is completely same to this solution, so that our vendors do not see each other. So those are two possibilities, and that is for our organization to choose what is the better solution for them.
Okay, thank you, Jelena. Any more questions? Okay, I believe then we can go on the next paper.